The process begins inside a controlled laboratory, where chili seeds are carefully screened for uniform size, color, and viability. Only consistent seeds move forward into mechanical treatment, where rotating drums apply protective coatings that stabilize and prepare them for automated planting. At this stage, raw biological material is standardized, ensuring every seed entering production behaves predictably within an industrial workflow. Prepared soil is fed into automated systems that distribute, level, and form planting cells across moving trays. Precision equipment shapes each cavity, while robotic placement ensures accurate seed positioning and spacing. Immediate watering initiates germination, and filled trays are stacked and transferred for early development. The process maintains a continuous flow from loose substrate to structured nursery units ready for controlled growth. Seedling trays move into enclosed environments where temperature, light, and moisture are tightly regulated. As germination stabilizes, plants transition into large greenhouse areas supported by automated irrigation, nutrient dosing, and spectrum-adjusted lighting. Biological pest control and routine inspections maintain plant health, while constant data collection allows conditions to be refined as seedlings strengthen before field deployment. Parallel to greenhouse development, outdoor fields undergo large-scale conditioning. Soil is plowed, leveled, amended, and tilled to form stable planting beds. Irrigation networks are installed, pressure tested, and integrated beneath protective mulch layers. This transformation converts open land into a controlled agricultural system capable of supporting uniform planting and consistent crop management. Once ready, greenhouse-grown seedlings are transported to prepared fields. Automated planters and robotic systems create openings, insert root plugs, and secure plants within the soil. Compaction stabilizes each transplant, while supplemental watering and manual adjustments ensure proper establishment. The transition connects nursery precision with field-scale cultivation. Irrigation systems are activated and digitally programmed to match plant demand. Nutrients are injected into the water supply and distributed through drip lines directly to root zones. Sensors monitor moisture levels in real time, while centralized software adjusts flow and timing, maintaining a controlled supply of water and minerals throughout the field. Continuous monitoring follows as drones, sensors, and laboratory analysis track plant health and development. Data highlights nutrient imbalances, pest presence, and growth variations, guiding targeted responses such as spraying, biological control, and manual maintenance. These interventions stabilize the crop and protect uniform development toward maturity. Move into reproductive stages under monitored conditions, producing flowers and forming food. Pollination occurs naturally while growth milestones are recorded. As chilies mature and change color, harvest planning begins, aligning equipment, logistics, and timing to capture optimal quality. Mechanical harvesters and robotic systems remove ripe chilies and transfer them onto conveyors and transport units. The crop flows directly from plants into collection systems where it is sorted, labeled, and staged for movement. Biological output is now converted into bulk agricultural material ready for industrial handling. Loaded trucks carry harvested chilies from the field to processing facilities. Incoming weights are verified and unloading begins as the peppers enter hoppers and conveyor systems. The workflow shifts from agricultural operations to structured factory processing. Within the facility, chilies pass through air cleaning, washing, and rinsing stages to remove soil and debris. Optical inspection systems evaluate color and shape, separating defective material from the main stream. The product becomes standardized before entering thermal processing. Chilies move into industrial drying systems where heat and airflow reduce internal moisture. Sensors and digital controls track conditions until stable storage levels are reached. Fresh produce is transformed into preserved material suitable for long-term handling and processing. Dried chilies enter destemming, seed separation, and grinding systems that convert them into flakes and fine powders. Particle size is calibrated and graded through mechanical sorting, producing consistent spice outputs ready for storage and formulation. Finished chili powder is transferred into sealed silos for controlled storage. Samples are extracted and analyzed to verify heat level, color, and moisture content. Quality validation ensures the material meets industrial specifications before further processing. Powder and roasted chili components are blended or processed into paste depending on the final application. Ingredients are added, mixed, and stabilized in controlled tanks. At this stage, the raw agricultural crop has been fully transformed into standardized industrial chili products prepared for downstream packaging and distribution.